Hello fast learners, welcome to our YouTube channel where we bring knowledge closer to you by just a single click button. Today we are going to look at molding sand under Foundry practice. What is molding sand? We need to know that molding sand, this one is commonly used sand for making all types of molds, irrespective of whether they are ferrous or non-ferrous metals. We need to know that most of the casting operations make use of what we call silica sand. And we need to know that sand used for foundry practice should be held under the mixture of water and clay. Clay acts as a binder such that the particles are held together. Therefore, one should know that a typical mixture has to be having 0.89 sand, it should be 0.04 water and 0.07 clay. We have different types of molding sand we are going to look at. We are going to look at green sand, we are going to look at patting sand, we are going to look at dry sand. But before we go to these different types of sands, let's first see what are the characteristics of molding sand. Molding sand, it should be refractory. What do we mean by refractory in nature? Refractory in nature in that it can withstand temperatures of molten metal, because we know we are going to be dealing with molten metal, so we have to make sure that our molding sand is refractory in nature such that it does not fuse when molten metal is poured into the moldy cavity. Then molding sand should not be chemically reactive to the metal we are going to be casting, so we have to make sure that it is not chemically reactive. We need to also know that the molding sand should have a high degree of permeability. What do we mean by permeability? There should be easy exchange of gases. It can be gases, it can be steam. So this is a very good characteristic that we have to put into consideration. And we need to know that the strength, permeability and hardness of the sand mix can be varied depending on the changing structure of the sand. Therefore, those are the characteristics of molding sand. But we have what we call the types of molding sand. Like I have said, we have green sand. What is this green sand? So green sand is just simply a sand that has been used in its wet condition for making our mold. So it is a mixture of silica sand, and this can be around 15 to 25% clay and should be around 6 to 8% water. Our green sand molds, we need to take note that they are not dried. So the molten metal is poured into them when they are wet. That is the difference between green sand and dry sand. So dry sand is simply sand that has been dried or baked under a furnace. So we need to know that that is the difference. The difference is that this one is used when it is not dried. It is used the way it is, but dry sand, it is used when it is baked. Therefore, we need to know that when it comes to green sand, being that it is damped, it can easily be worked on by hand to give it a desired shape. Then we all have to also know that the sand is used for producing small and medium-sized molds that are not very complex. So we have another type of sand or molding sand, that is dry sand. Like I've said, this one is sand that is, it has been green sand, but it has been baked and used for preparation of the mold. So drying sands, we need to know that they give the strength of the mold. They provide the strength to the mold, and it can be used for larger castings. Then we have another type of sand. We have what we call the loam sand. So this is sand containing up to 50% clay. Remember, I've said that clay is just a binder. So it contains 50% clay, which has been worked on consistently by the builder motor. The builder motor is just a mixing machine. It keeps on mixing those proportions of sand in order to get what we call the loam sand. But this loam sand, we have to make sure that it contains 50% clay. So we need to know that when it comes to loam sand, it is used for making heavy castings, usually with the help of what we call the sweep and the skeleton patterns. In our previous video, we talked about the sweep and the skeleton pattern, whereby we said the sweep makes use of what we call the wooden board. So it creates a cavity by rotation of the wooden board along the vertical axis. Then we looked at the skeleton patterns as well. Then we have another type of sand, which is the patting sand. What do we call the patting sand? So patting sand is simply the sand used during the making of the mold to ensure that the green sand does not stick to the pattern. we have our flask. The flask comprises of what we call the cup. It comprises of what we call the drag parts. So in order for us to ensure that the cup and the drag can easily be separated when removing the pattern, we have to make sure that we put what we call, or we incorporate what we call the patting sand. So this patting sand allows easy separation of the cup and the drag, and this prevents what we call damage of the mold cavity. Then we need to know that our patting sand consists of what we call grained clay free-dried silica sand. They are very small, tiny particles. An example, it can be sea sand, oil burnt sand. Those are examples of patting sand. So we need to also know that the patting compounds, we may use also charcoal, we may use ground bone, we can use limestone, we can use groundnut shells, we can use talc, we can use calcium phosphate. All those are different patting sands we can use. Then we have another type of sand. This is the facing sand, I beg your pardon. So this is sand that covers the pattern all around. We have to find that if we have our flask, what we call the molding box, so the remaining box is filled with an ordinary floor sand. So this floor sand is what we call the facing sand. So the facing sand forms the face of the mold and comes in direct contact with the molten metal when it is poured. So we have to make sure that we pour our facing sand such that our molten metal comes into direct contact of this facing sand. We need to know that our facing sand should have high strength and it should have a property of refractoriness. What do we mean by refractoriness? I'll say that ability to withstand these high temperatures. We need to know that also that our facing sand is made of silica sand and clay without addition of any used sand. So this is simply a mixture of silica sand and clay. Someone can put what we call graphite and molasses can also be incorporated in our facing sand, and have to make sure that our facing sand has a layer which varies from around 20 to 30 millimeters. Then we have another type of sand. This is the baking sand. So baking sand is a bulk type of sand. So this one is simply used for backing up the facing sand to fill up the volume of the flask. So you keep on backing those missing parts, those incomplete parts, with what we call the backing sand. So it consists of mainly old repeated. It is mainly old in that it is used several times. So we have to see that we use the backing sand multiple times, of course. So it is used where facing sand is not enough, simply that. So because of the color of the baking sand, so sometimes we call it black sand because it is somehow black, but we call it black sand at times. So we need to know that the main purpose of the backing sand is to reduce the cost of molding. That's why we use the molding sand. Then we have another type of sand, though this one is not so common. That is the system sand. So this is the sand used for mechanized foundries. Mechanized foundries, we mean those foundries that are automatic, they are automated. Those are mechanized foundries. So these ones is where we use the system sand. So it is used for filling the entire flask. So we need to know that when it comes to the system sand, we don't incorporate what we call the facing sand. No facing sand is required when it comes to mechanized foundry where we use the system sand. So we need to know that the sand, first of all, is cleaned and reactivated by the addition of water and binders, which are filled in the flask. And because of the absence of any fresh sand, let me say which would be the green sand or the dry sand, the system sand must have more strength. It should have a good permeability. It should have a property of refractoriness compared to the backing sand. So simply need to know that when it comes to the system sand, it's simply used under mechanized foundries. Then we have what we call the koala sand. The koala sand is simply used for making of cores. We looked at cores and we said that cores, they are used for creating sections of castings that are hollow. So koala sand is sand used for making cores. So this is silica sand mixed with koala oil. That is why it is called oil sand. It can be referred to as koala sand or oil sand. So the koala oil consists of what we call the linseed oil. It consists of resin, it can consist of light mineral oil with some binders. So we need to know that for larger cores, sometimes we use either the pitch or the flow and water may also be used to save the cost. So you find that Koala Sand, simply its main function is to create what we call the koalas. Then those are some of the different types of molding sand. What are the different properties of molding sand we have? Because we've seen green sand, it looks differently from the dry sand. We've looked at the facing sand, we've looked at the parting sand, so backing sand and so forth. So what are the properties of the molding sand? What are those characteristics that these different types of sand give in order to create our moldy cavity? First of all, we look at a property known as strength. Strength can be in three forms. We have what we call the green strength, we may have the dry strength, we may have the hot strength. So all those are different strengths. It's a property of the molding sand. When it comes to green strength, we need to know that adequate strength and toughness for making and handling the mold, that is green strength. Then when it comes to dry strength, we need to know that dry sand must have strength to resist erosion and also metallurgical static pressure, or metallo, someone may call it metallostatic pressure of the molten metal. So we need to know those strengths are required. The dry strength is required, the green strength is required. Also we have another one which is the hot strength. So the hot strength is simply the strength of the whole molten metal, as simple as that. Then we have another property, that is permeability. We've said that permeability, this ensures steam and other gases easily escape. That is all about permeability. Then we have what we call thermal stability. So when it comes to thermal stability, we need to know that heat from casting causes, heat from this casting, of course we say that the casting is the final product. So heat from the casting causes what we call rapid expansion of the sand surface. So we need to know that if there is expansion, remember there is expansion on heating and there is contraction on cooling. Are you getting it? So we need to ensure that does our sand withstand the high temperatures? If yes, then that is thermal stability. So thermal stability is that it does not fluctuate with respect to the different temperatures of the molten metal. Then we have another property, that is refractoriness. Of course, refractoriness in that it has to be able to withstand the high temperatures. So we need to know that it shouldn't melt, it shouldn't soften, so it should adhere to the properties of the molten metal. Then we have what we call flowability. Flowability, like it says, we should make sure that our sand does what we call packing well. It packs well or flow under load. So that is what we call flowability, and we have to make sure that sand of low flowability may result into what we call a non-uniform hardness. So that is also a property. Then we have a property known as collapsibility. Collapsibility enables us that when it comes to removing of our final product, which is the casting, our molding sand should easily collapse easily, such that we withdraw out our final product. So that is collapsibility. Then we also need to know that besides these specific characteristic properties we've looked at, we need to know that the molding material should also be cheap, it should be reusable, and it should have a good thermal conductivity, because we cannot look at only collapsibility, permeability, strength without looking at being cheap, being reusable, and being with a good thermal conductivity. That is also other properties that we have to put into consideration. Then we have other properties that may not be put into consideration, although they are very essential when it comes to creating a sound molding sand. We have what we call adhesiveness. Adhesiveness, these work hand in hand when it comes to collapsibility. So the molding sand should collapse during the contraction of the solidified casting. I repeat, when it comes to adhesiveness, we mean that the molding sand should collapse during the contraction of the solidified casting. So it does not provide any resistance, that is adhesiveness. So because if it provides any resistance, this may result into what we call the cracks in the casting. Then we have cohesiveness. that is also a property, because we know very well that cohesiveness and adhesiveness go hand in hand. Therefore, cohesiveness may be the opposite of adhesiveness. I hope that is clear. So cohesiveness becomes a property, adhesiveness also becomes a property. We have another property, reusability. We are going to see that reusability in that we have to use this molding sand multiple times, because we are trying to reduce what we call the cost. So if we are to use a lot of molding sand for large quantities of castings, we need to make sure that our molding sand is reusable, such that we cut what we call costs. Then another property can be easy preparation and control. Our molding sand should be easily be prepared. So the sand should lend itself easy preparation and control by the mechanical equipment. So that is easy preparation. It should permit use of machines during its preparation. Then we have another property, which is conductivity. Of course, sand should have enough conductivity in order to permit removal of heat, because if we remain with heat, we are going to face what we call shrinkage problems. But if we have conductivity of the molding sand very well, that means we are going to ensure that there is easy escape of heat from these castings. That's all what I had for you. Another subtopic next time, I think we shall be looking at the tools and equipment used in preparation of the molding sand. We shall see the ladles, we shall see the different tools used in preparation of the molding sand, and then after we shall look at the preparation of the mold cavity. Thank you for listening. Don't forget to subscribe to our YouTube channel, comment where necessary. Thank you very much.